Hello everyone and welcome. Today we're going to discuss casting and type conversion, which generally refers to modifying a data type into another data type. In order to perform an operation on two data types, we need to convert both of them to the same data type. And type conversion is of two kinds, implicit and explicit. Implicit type conversion, also known as hidden conversion, is only possible when there is no risk of data loss, like for instance when converting from a lower range number like an int to a higher range number like a float. And the reason why it's called implicit is you don't need an operator for it, it's performed automatically like so. So we assign the int to the float and it worked. This list displays the possible implicit conversion of primitive data types, and don't struggle to memorize it. Most of these data types you won't even use very much, if ever. Just as a side note, notice that some of these data types have weird names compared to what I told you in past lessons like uint or sbyte. The u actually means unsigned, so unsigned int, meaning an int that cannot store negative numbers, but the range of positive numbers it can store is doubled. On the other hand, the s come from signed, so signed byte, meaning a byte that can store negative numbers and so on and so forth. These are not that much used nowadays, they are called type modifiers, and you as a beginner don't actually need them. That's also the reason why I haven't mentioned them when I talked about variable types. Explicit type conversion basically means I know what I'm doing, so let me convert this into this because I know it will work. And it is performed whenever there is a possibility of data loss. Like for instance, when converting any real number into an integer, there is always a possibility of data loss because the integer cannot store the fractional part. But as long as you don't care about that fractional part, the explicit conversion will work just fine. Also, as mentioned previously, when converting from a wider range number into a lower range one, there is a possibility of data loss because obviously the wider range can store a bigger value than the narrower one. Explicit type conversion is done by putting the type into which you want to convert between parentheses in front of the type to be converted, like so. And the reason why this works is that the value of the double is small enough, 2.3, is small enough to fit into an int. And we know that the fractional part will be lost, but we don't care about it. However, this will fail miserably because the maximum value an int can store is about 2.14 billion positive, and we are assigning to it a double to which we assign a value of 7 billion. So we will not get an error, but the value will not be okay due to something called overflow, of which we will learn at some point. Anyway, pretty much any numeric data type can be converting using this method, but with the possibility of data loss in some cases like you just saw. But when it comes to strings, it's not that simple. Sure, when converting from any data type into a string, it's easy. And it works. But obviously you can't add a string and an int. That's not how addition works. What is actually happening is the int gets implicitly converted into a string because whenever you have a string operand, regardless of the type of the other operand, the program will implicitly convert it into a string and then join the two strings into a new one, operation called concatenation. And because of that you should be careful, because concatenating operator plus has the same precedence as the addition symbol, also plus. And where you might want to add two numbers and then concatenate them with some string, but you might get the surprise of actually getting all the three values concatenated, like so. So 3, 7, not 10. And this actually happens because whenever you are dealing with operators with the same precedence, the order of operation is from left to right, whichever comes first. So in our case, we have the string plus an int, which needs to be implicitly converted into a string, and those strings will be concatenated, which will result into a new string, which needs to be added with the second int, which needs to be implicitly converted, and so on and so forth. So pay special attention to implicit conversion because it can be dangerous, and if you can, you should avoid it. Instead, you should try forcing the order of operation as explained in a previous lesson, and this will work. So it's 10, because parentheses come before concatenation or addition. When we talk about conversion from string to other data types, especially numeric, that's another story. Because as you can imagine, the string can be a valid number, but it also can be anything else. And because of that, conversion from string to numbers is a bit more tricky. Most input that a user will enter into a user interface, be it a text field or a console app, will be received by that app as a string, even if that text represents a number. And we previously used console readline to read text from a console, so we could have something like this. And with this, we could read anything from the console and into the string variable. Now let's see how you can convert it into an int. The first way would be to use the parse function, like this. And if I run it, and I enter 57, it works. But if I run it again, and I enter the words 57, the program will crash. And that's because for us humans, the words 57 mean the number, but for the compiler, they don't. For all it cares, it could be a romance novel. If I run it again and I enter it slightly modified, for you, the textual representation of this will not change in your mind because you can understand that the dash can be safely ignored. But the compiler can take this kind of decisions. For it, if the text is not precisely identical to the numerical representation, it can convert it. Done. And other data types have the parse method to convert from string, like byte.parse, boolean.parse, decimal.parse, and so on. The next way of converting text to numbers is to use the TryParse function, which works the same way, but instead of crashing the program if the conversion fails, it returns a boolean result indicating whether the conversion succeeded or not, and it looks like this. If I call it with a valid value, it works. If I call it with an invalid one, it doesn't work because we get 0, but it also didn't crash the program. I know we haven't talked about out parameters yet, but just remember that the TryParse function returns a boolean indicating if the conversion succeeded or not. But we also need the converted value itself, and because of that we get it as an out parameter, which then we can use as if we declared a regular variable. The third way of conversion is by using the convert class itself, which contains a bunch of conversion methods, some of which are suitable for string to numbers conversion, and it can be used like this. It works the same way as the parse version, but there is one big difference between them. This version will also convert strings that are null, and the result will be 0. If this video helped you, click the like button. If you feel adventurous, also the subscribe one. And until next time, thanks for watching, and I'll see you in the next tech frame.